Hey guys, I want to start with a question here. We're going to be learning about something called piecewise functions today. So I just want to know if you've ever heard of a piecewise function before, maybe in Algebra 2 or another class. All right, so let's go ahead and talk about what a piecewise function is. This is a graph of a piecewise function, and we are going to look at how to graph these. Your assignment will be to use this graph and also plug some numbers into a piecewise function. Not graphing it from scratch, but you'd be able to use a graph of a piecewise function. All right, so a basic definition of what a piecewise function is. It's when a function is defined by different equations on different parts of the domain. So what I mean by that is we've talked a lot about domain recently. Domain is the set of x values. So this particular example here, you can see we have one curve here. This is actually y equals x squared. But that's only for a specific domain. It's only from negative infinity up to the point 1, 2. So on this interval of the domain, that's the function, y equals x squared. However, at the point 2, x equals 2, we're actually using the equation y equals 6. And that's only for point 2. And then we've got this other function, y equals 10 minus x, which is true for the domain from 2, not including 2, but just to the right of 2, up to 1, 3, 4, 5, 6. So 2, 6 with a bracket because it's filled in. So this is what we call a piecewise function. We have these different pieces. We have a piece for the domain negative infinity to 2. We have a piece for the value of 2. And then we have another piece for 2 up to 6. So this sort of has 3 different pieces. So that's called a piecewise function. So we're going to be looking at graphs like this today. I'm going to go through on how we would graph these, and then we'll talk about finding some values. You'll have an assignment on delta math, which you're going to be looking at the graph and finding some values, and then also making some substitutions and finding values as well. So let's start with the most basic piecewise function that there is. This function is given by these two equations, x if the x value is greater than or equal to 0, and negative x if the value is less than 0. Typically, we just see the domain written in this form, the x plus or minus whatever, rather than the interval notation specifically for piecewise functions. All right, so to graph this thing, I'm just basically going to start with this first function, x, and make a little xy chart. Now this says for all values of x, 0 or bigger. So I'm going to start by just plugging in 0. Plug in 0, you get 0, right? You plug in 1, well, you get 1 out. And this is for, again, f of x equals x. You plug in 2, you get 2 out. And 3, you get 3 out. You know the deal. All right, so if I were to start graphing this, 0, 0, 1, 1, 2, 2, 3, 3, this would just look like this. And notice I put a solid dot there at 0, 0 because it does include that point. Now my other function, f of x equals negative x, I want to make a little chart for that as well. Although I'm not including 0, I'm going to go ahead and plug 0 in because I know there's going to be an open dot at that point. Well, negative 0 is still just 0. If I were to do now negative 1, because I want numbers less than 0, so I'm going to start plugging in numbers that move this way. So negative 1, negative 1 will become positive 1. Negative 2, well, negative 2 will become positive 2. Negative 3 would become positive 3, so on and so forth. So what you'd end up with is negative 1, 1, negative 2, 2, negative 3, 3, like this. And at 0, 0, it would be an open dot. Now, since there's already a filled in dot there, it doesn't really matter. But what you would have happening here is this. And if you remember from our parent functions, this actually looks eerily similar to the function f of x equals the absolute value of x. And that's actually what this is. This is a piecewise function which represents the absolute value of x. So this is sort of the intro basic concept of a piecewise function. We use the equation negative x for all values less than 0, and then we use the equation positive x for all values 0 or bigger. So if, for instance, question, if I ask you, what is the value of f of 3? What is that? Well, two ways you could do this. You could plug in, figure out where you need to plug it in, first of all. For 3, since that is bigger than 0, you would plug it into this equation, right? And it says, well, it's just x, so it would just be 3. Or what you could do is you go to 3 on the x-axis. Here's 3. And figure out what the y value is. The y value there is, well, 3. This is 0.3 comma 3. So either way, you would get 3. And we'll do a fair amount of practice of this. All right, let's look at a little bit more complicated one. So this one is defined by two equations, 2x plus 3 if x is less than 0, and negative 1/2 x plus 3 if x is greater than or equal to 0. So I'm going to start with the first function. F of x is 2x plus 3, and make a little xy chart. If you are asked to graph this, you always want to start with whatever points are given there. So I want to start with 0 because that's what it tells us. So if I plug 0 into this function, I'd do 2 times 0, it's 0 plus 3, so I get 3. Now, I don't need to plug in a 1 next because this is only for values less than 0. So I would want to do negative 1 next. 2 times negative 1 is negative 2, plus 3 would be positive 1. Well, let's plug in negative 2. They give us negative 4 plus 3, which is negative 1. Do one more. Negative 3, negative 6 plus 3, which would be negative 3. All right, so I'm going to go ahead and plot these. Now at 0, 3, since I'm not including it, since it's just the less than sign, I'm going to put an open dot at 0, 3. 0, 1. Open dot. Negative 1, 1 would be here. Negative 2, negative 1 here. Negative 3, negative 3 would be here. So you can see what's happening here. Linear equation like that. I'm going to switch colors for my next one and do my second function. F of x is negative 1/2 x plus 3, and that's for values 0 or bigger. So I'm going to start with 0. If I plug 0 in, 0 times negative 1/2 is 0 plus 3. I do get 3. If I plug in 1, negative 1/2 plus 3, that's going to become 5/2, or 2.5. If I plug in 2, it's going to be negative 1 plus 3, which would be 2. And if I were to plug in 3, again, only plug it in numbers bigger than 0, would be 3/2. So if I were to go ahead and graph this, my first point is 0, 3. So I'm actually going to go ahead and just fill that dot in that I originally didn't have filled in. 1 comma 5/2, which would be here. 2 comma 2. 3 and 3/2. All right, so you can see what's happening here. There are my two equations for the two different parts of the domain, making a piecewise function. All right, so those are both pretty basic. Get a little bit more advanced with this next one. Notice my domains aren't just restricted at 0 this time. We got a little bit more happening here. And we have 3 functions. It works exactly the same way. I'm just going to start with my top function there. F of x is negative 2x plus 1. Select some x and y values. Now, as I said before, you always want to use the number up here in the domain. So we do want to use negative 3 as our first one. This is for values between negative 3 and 1. So I might want to use also like negative 2, negative 1, 0, and then make sure I end with 1. Be good. So if I plug these in, negative 2 times negative 3 is positive 6, plus 1 is 7. Next one would be 5. Then I get 3, and then I get 1, and then I get negative 1. So I'm going to go ahead and graph these. Now my first dot should be solid because it does have that or equals to, and this one should be open because it does not. So negative 3, 7. Be up here, solid dot. Negative 2, 5. Here. Negative 1, 3. 0, 1. And 1, negative 1. Now, at 1, negative 1, it should be an open dot. That's my ending. So this is a linear equation, like that. Now my next equation is pretty simple. Oops. I'll change colors here. So my next equation is just f of x equals 2. But now this is only for one value at x equals 1. So that means that the only number I can plug in is 1, and it automatically equals 2. That's it. So that means the point 1, 2. 1 right here. So that's going to be a solid dot. So sort of filling in that hole. And then my last function, f of x equals x squared. And this is for all values greater than 1, but I do want to start with 1. 1 squared is 1. So then bigger I would want 2. 2 squared is 4. 3. 3 squared is 9. 4. 4 squared is 16. Should be fine. So I'm going to start with 1, 1. And I'm going to put an open dot because it is not solid. Not have the line on. Oh, sorry. Open, because it does not have a line under it. All right, so I've got 1, 1. Then I got 2, 4. 1, 2. Here. 3, 9. Here. And I won't be able to do the next one. But what's happening here, this also, if you remember, this is x squared. Remember, that's a U shape. So it is important to know what we should be expecting for that. We know it should be a U shape. So this is part of the U here. So it should be rounded. It shouldn't be a solid line. All right, so that is my piecewise function. I've got 3 parts to it, making sure I have the right open dots and the right solid dots. This will continue to go on for infinity, but it does stop in the negative direction there at -3. So eventually we may get to graphing these, but for right now I just want you to see these, and we're going to be doing some delta math assignments using these. Some questions that you might get asked are like, based on this graph, well, what is f of -2? So for you to do that using the graph, you would go to -2 in the x, because remember this is f of x, so it means what is -2 x value? If we go up and look at the y value there is 1, 2, 3, 4, 5. So that would be 5. In the same way that if you were to plug it into the function, f of -2, well, that goes in this one, because -2 is between -3 and -1. So you could also go -2 times -2, substitute for the x plus 1, gives you 4 plus 1, which is 5. So either way, you can come up with the answer. So let's flip over to delta math and look at the first thing you're going to be asked to do, and that is going to be to evaluate these piecewise functions graphically. So we're going to be given a graph of a piecewise function, and you need to figure out what the value is. The first one here is f of -5 is what we're supposed to find. What I want you to remember is that these are f of x values. All right, so just remember this is f of x, meaning that the 5 is actually -5 there is an x. So we're going to look at x equals -5. What's happening there? Well, if we go to -5 in the x direction, 1, 2, 3, it'll be right here. The value we actually need to look up. The value there is the y value we're looking for, which is 6. So our answer for this is going to be 6. We want the y value. So let's try another one. So this is a different piecewise function. So this is f of x here, f of 1. So again, 1 is the x value. Basically, we want to know what is the y value. What is the y value at x equals 1? That's what we're asked to find. What is the y value at x equals 1? So we go to 1 on the x-axis, which is right here. And then we just look for the y value. The y value where the curve hits is right there. And that looks like it's -3. So f of 1 would be -3. Remember, there is always these help videos as well, so feel free to watch those. Let's go ahead and look at one more here. This one we're supposed to find f of 6. So basically we just need to find the right curve. Remember, this is the x value, 6, so we just go to 6 on the x-axis. You can even circle it if you want to. And then find the function. The function is up here. We want to know what is the y value at x equals 6. Well, the y value there looks like it would be at 5. Y equals 5. So that's really all there is to it. Let's go ahead and look at the other type of problem, which you're going to be asked to do, which is to evaluate these piecewise functions. All right, we're actually starting off with a little bit of a confusing one here. But what you're supposed to do is we're asked the same question, except we're given the function and not the graph. So we're supposed to find f of 3. So again, what is y value when x is 3, basically? Well, this one, the reason why it's a little confusing is you got to figure out basically what function to plug 3 into. That's your first question. Well, if I look at the top one, that says for values between 0 and 3, but it does not include 3. 3 is not included. So think, well, how about the other one? Well, look at this one. 3 is also not included in that one as well. So there's actually no good place to put in 3, which means 3 has to be undefined in this because it's not defined anywhere on the domain. So this one will actually just be undefined. See if we can get a better example for the next one here. All right, the next one, we're supposed to find f of negative 3. So the first thing you have to make, first decision you have to make is decide which function. Decide which function or which equation. And then the second thing you do is plug the x value in. So if we do that, we're looking for negative 3 as the x value. All right, so which one do we plug in for negative 3? The top one we use for any value except negative 3. Right, this is say if we had any number, if this was f of 5, f of 1, f of negative 10, f of negative 100, we use the top one. But if we're looking at x equals 3, if we're looking at negative 3, then this is going to be our answer. This is our y value, our answer for x of negative 3. So our answer then is negative 4. So let's try a couple more here. This should be a good one. All right, so our first decision, figure out which function to plug this into. This is our x value again, negative 2. So look at the first one. First one says we use this one for all values less than or equal to negative 1. Think about if that goes in there. The next one's between negative 1 to 3, and the last one is greater than 3. So think about for a sec which when we plug it in, and we do the top one because negative 2 is less than or equal to negative 1. So we're going to plug it into the top. So f of negative 2 would then be negative 2 times negative 2. So replace the x with negative 2. That gives us 4. All right, and let's do one more here. Same thing as before, we need to first make a decision based on the x value. X value here is 1. So figure out which function. The top one is for values less than 3. 1 is less than 3, right? So we do want to choose the top one. So we're going to plug 1 in for the x. It's going to be negative 1 minus 2 squared minus 3. Evaluate this. Get negative 1 squared minus 3. Negative 1 squared is positive 1, so negative positive 1. So it'll just be negative 1 minus 3, which is negative 4. That's our final answer. All right, if you're still struggling with that, make sure you do reach out for help. Or again, there is the help video on this as well. Click on watch help video and there'll be a video you can watch. Probably it's kind of similar to the way I showed you, maybe a little bit different. They sometimes have a little bit different approach that might make more sense to you. All right, good luck.